In previous lecture, I have discussed about impulse function or unit impulse function. Unit impulse function is basically a rectangular pulse of zero width. Unit impulse function is a rectangular pulse of zero width, but at t equal to 0, its amplitude will be tending toward infinity. This is the characteristics of impulse signal or impulse function. And mathematically, you can express impulse signal as, if delta t is impulse signal, then its amplitude will be 0 everywhere or for any value of t, but it is undefined. But it is undefined at t equal to 0. So by this expression, you can represent mathematically impulse signal. Second thing which I have discussed in previous lecture, the area under, if the area under the impulse function, if area under the impulse function, this is the area which is included in impulse function from minus infinity to plus infinity, if you will calculate the area of this signal, and if this area is unity, then the impulse signal will be unit impulse signal. So you can represent unit impulse signal through this integration also. And third characteristic which I have discussed, already I have discussed in the previous lecture, that you can get unit impulse signal just by differentiating unit step signal. So just to go through the previous video in which I have discussed all the characteristics and you can say all the characteristics of unit impulse signal. In this lecture, I will discuss some fundamental or some of properties of unit impulse function, and which is desirable to analyze various types of signal, or you can say uh, these property uh, which I will discuss today will be very important to solve some mathematical expression in which impulse signal has been included. Before proceeding to the property, before coming to the property, before the discussion, uh, one thing I would like to incorporate here, the impulse signal is also called generalized function. Impulse function is also called generalized function. And for the generalized function, you must remember this integral. This integral is very important, and I will consider this integration in the discussion of the property of unit impulse signal. If G is the generalized function or your impulse function, you must remember your impulse function is generalized function. And if differentiation of generalized function is multiplied with any test signal, then from the property of the integration, you can change this integration as minus infinity to plus infinity, and this differential will come on xt, and this will become simply gt, and this differentiation will now appear at test signal dt. These two integral will be equal to each other. With the minus sign, these two integral will be equal to each other, and you can get this through the property of integration. So you must remember this. I will consider this integration in the discussion of the property of impulse signal. And the second thing you must remember, the impulse signal is not defined at t equal to 0. At t equal to 0, you cannot define the amplitude of the impulse signal. And except t equal to 0, everywhere, for any value of t, its amplitude will be 0, except at t equal to 0. But at t equal to 0, you cannot define its amplitude. It will be tending toward infinity. So you must remember this. Now, I am considering Sputt's property, which is called shifting property. This is very important property, shifting property. According to this property, you can evaluate this integration easily. Suppose this is an impulse signal, delta t, and it is multiplied with any signal xt dt. The value of this integral will be equal to the value of xt at t equal to 0 or x0. This is shifting property. And you can easily prove this relationship. As you know, for any value of t, delta t will be 0. So this product delta t into xt will be 0 for any value of t. Integration is basically summation of this product from infinity to plus infinity. When you will put the value of t, 1, 2, 3, minus 1, 2, minus 3, if you will put any value of t, you will get this product equal to 0, because delta t is 0 for any value of t except at t equal to 0. You must remember this. So you can write this integration because this product is only everywhere this product will be 0. Only at t equal to 0, you cannot get the value of this product because delta t is not is unknown at t equal to 0. So this integration will be changed to this integration, or you can change this integration delta t xt by delta t x naught dt, because everywhere this product will be 0 except at t equal to 0. So this integration will change to this. Now x naught is constant. Now x naught will be constant. So it will come outside the integration, and this is minus infinity to plus infinity delta t dt. And this integration represents the area of delta t from minus infinity to plus infinity. And as you know, the delta t is unit impulse signal. So the area, if you will calculate area of the impulse signal from minus infinity to plus infinity, you will get 1. So this will become equal to x naught. In this way, you can justify this statement. So this is called shifting property. And this property is very important because if I am asking you, calculate this integration. Delta t and sine square t plus 3t square plus 5 dt. For example, I am asking you to integrate this. So in this question, you can use shifting theorem. You can consider this as xt. So this integration will be minus infinity to plus infinity delta t xt dt, xt dt. And according to the shifting property, this will be equal to x naught. So you have to substitute t equal to 0 in this expression. You will get the value of x naught because xt is known. So if you will put t equal to 0, then you will get 5. So by using shifting property, you can integrate this integral without the use of integration by part. You can easily integrate it. So this is very important. Suppose I am asking you, what will be the value of delta t cos square 2t dt? What will be value of this integration from minus infinity to plus infinity? So in this example, you have to consider this as xt. So this integration will be delta t xt, which will be equal to x naught. And how you will get x naught? Just you have to substitute t equal to 0 in this cos square 20, you will get 1. So in this way, you can easily integrate the function mathematical expression, which includes impulse signal in it. So this is the advantage of this shifting property. And the second shifting property is if test signal is multiplied with shifted impulse function, then what will happen? This is property 2. This is property 2. Suppose this integration is from t1 to t2. And in this shifted impulse function is multiplied with any signal. And now the question is to calculate this integration. How you will calculate? First, you have to check whether the t naught lies in between t1 or t2 or not. If t naught will lies in between t1 and t2, then plot of this shifted impulse function will be like this. Here minus sign has been used, so the impulse signal is shifted in right direction by an amount t naught. And you must remember now this impulse signal is not defined at t equal to t naught because now it is shifted by an amount t naught. And this is t1 and this one is t2 if t naught is lies between t1 and t2. This will be the plot for this shifted impulse function. This is a shifted impulse function. Now, from the definition of impulse signal or unit impulse signal, you can say this impulse signal is not defined at t equal to t naught. And except t equal to t naught, everywhere the value of delta t naught will be 0. Or you can write it delta t minus t naught will be 0 everywhere except at t equal to t naught. And at t equal to t naught, it is undefined at t equal to t naught. So you must remember it. So you cannot calculate, you cannot estimate the amplitude of delta t minus t naught at t equals to t naught. But except t equal to t naught everywhere, this product will be 0. So now this integration will change now. This integration, you can write this integration as t1 to t2. And everywhere this product will be 0 except at t equal to t naught. So you can write it delta t minus t naught x t naught. Only at t equal to t naught, you are unable to define this product. So this integration will change to this integration. Now, xt naught will be constant. So it will come outside the integration. Outside the integration. And the integral will be t1, t2, and delta t minus t naught dt. Delta t minus t naught dt. This is the area of shifted impulse function in between T1 and T2. And obviously you know that the area included in this impulse signal is unity. So this will become xt naught. Xt naught. But you must check whether T naught is lie in between T1 or T2 or not. If T1 does not exist, does not lies between T1 and T2, then the value of integration will be 0. This integration, you can define this integration as t minus t naught xt dt will be equal to xt naught only when t naught lies between t1 and t2. Otherwise, the value of this integration will be 0. Otherwise, you can also verify this result. So you must remember, you have to check whether the shifted impulse by an amount through which the impulse signal is shifted, and suppose the amount is t naught, then you must check whether t naught lies between lower and upper range of the integration limit or not. If it lies, then it will become xt naught, otherwise it will become 0. So this is the shifting function. This is the shifting property of the impulse signal. This property already I have derived in this PDF file, and you can download this PDF file from LMS, and you can go through this derivation. Already I have derived it. Both the property I have derived. So you can go through this PDF file. In next lecture I will discuss about its second property, which is called sampling property.